second video for today. I wanted to start off by showing why do we even use the completing the square. I told you it was for graphing when you're doing transformations by hand, which you will see upcoming quizzes and tests. Okay? So we're trying to change this standard form to a vertex form for a quadratic. Okay, here we go. Our example is this one right here. So we have 2x squared minus 4x plus 5. What am I going to set it equal to, guys? 0. Okay, so here we go. First step. And this is as difficult as they get, because if you haven't noticed already, my A is not 1. And we know when A is not 1, there are more steps. Factor by grouping, or the step that I'm about to show you here. Okay? So let's move this 5 over, because we know the first step is to get our x's all on one side. If you don't know this by now, the triangle, like slope, this is the change in y over the change in x. So the triangle I'm going to use as a symbol that we need to change this 2 right now. We need to change that 2 to 1. To 1. Okay? So here we go. I'm about to GCF out just the 2 from the left side. What are the scraps? X squared minus 2x. Notice how I only did that on the left side. I just GCF'd. Okay, so don't divide the right side by 2. Don't do that. I didn't divide both sides by 2. I just GCF'd. And the reason why is because I'm completing the square. That piece that I know that exists on completing the square, that's very, very important. It's called b over 2 squared. It almost feels like you're doing negative b over 2a, but it's not the same. I need to look at where is that b, where's my new b. Okay, these are as involved and difficult as factoring gets, by the way. Okay? So, what's negative 2 divided by 2? Negative 1. Squared? 1. Plus 1. So guys, I just did a plus 1 on the left side. Guess how much I'm going to add to the right side? 1. I'm actually going to add whatever this number times that completing the square number becomes. So I'm going to put a little square there so that you know that was the completing the square piece. So 2 times 1, I'm really adding 2. See, the other one, it was exactly the same because A was 1. This one, A, was different to begin with. That's why we had to do this step right here. Here we go. We're going to factor this perfect trinomial. That will become x. This 1 is 1 because you're just square rooting it. And borrow the sign. Everything else stays the same. Are we good? What will I do now to get x? Divide by 2. So I have, I'm running out of room, I'm going to write it over here. Divide both sides by 2 will give me x minus 1 squared is equal to negative 3/2. Are we good? Everything's going well? Okay. So now what do I do? Take the square root of both sides. So if I take the square root of both sides on this one, I'm going to have x minus 1 is equal to plus or minus the square root of negative 3/2. see where I'm at right here? Did we understand how I got there? Okay. If I wrote this as 2x minus 1 squared plus 3 is equal to 0, is that allowed? Yeah, because I just added 3 to both sides. And now that I have this set equal to 0, it's almost like saying y is equal to all of this. So if I put y is equal to 2x minus 1 squared plus 3, now I can see my HK vertex, what am I going to write there? What's my H? 1. My K is 3, right? So what is my vertex? 1, 3. You all understand? So this form right here, when I get it equal to 0, I can actually see it like transformations. I can see it as vertical stretches, compressions, shifts, reflections, all of that good stuff that you guys are really, really good at. Okay? So 1, 3, 1, 3 is the vertex. The graph of this is shifted. How many units? What do I put? It's shifted. Come on, guys. 1 unit. Right. We'll just put an arrow. And what? 3 units up. Because with y, we follow the rule. Okay? If I were to keep going with this, yes, we could solve out what x would equal. And x would equal plus or minus, whoops, check this out, we're going to add 1 to both sides. So it would be a positive 1 plus or minus the square root of negative 3 halves. We'll talk about taking square roots of negatives here soon, but not today. Those are imaginary numbers. Okay? Questions? Okay. So now for group bonus points, what I want you to do, please do not work ahead. Do not use your calculator. Do not use your Chromebook. I want you to do, again, don't work ahead, but this is one of the examples from that completing the square activity. I want you to solve for x. What are your factors or what are your x solutions? What are the zeros of the function? But you can only do it by completing the square. So I want to see all the work. I will award you with bonus points. For the sake of time, I will give you 3 minutes. Go ahead and start. I'll see you at the end. Alright, so solving this, I want to work through it. We'll have one more example after this, but with the a coefficient is not 1. Okay, here we go. First step, get the x's to one side all by themselves. Because this is 1, I don't have to do that extra step. I can go right now to b divided by 2. I don't really care about the negative because it's going to become positive anyway. So 12 divided by 2 is 6. Squared is 36. So I'm really adding 36 to both sides. This becomes 16. Square root of that. Square root of that. Borrow that first sign. This is what I have. If I were to set this equal to 0, okay, just off to the side actually over here, and move this 16 over, this is the same as saying y is equal to all of this. So that my vertex would be 6, negative 16. The transformations that occurred are, it was a horizontal shift, 6 to the right, and a vertical shift, 16 down. The zeros of the function can be solved from over here. Ready? Here we go. I'm going to take the square root of both sides, plus and minus on that. So plus and minus 4 is equal to just what I have, because the squared and the square root cancel. And now I have 2 answers. X minus 6 is equal to 4. X minus 6 is equal to negative 4. Feels a lot like that absolute value stuff. So we should have gotten, no, not 2. We should have gotten 10, and we should have gotten 2. So my zeros, here we go. My zeros are right here and here. My vertex is here. My transformations are both of these. So each circle highlight, which there's 5 of them, is 10. If you're perfect, I'll double your score. So now this is your second example. 18x plus 3x squared is equal to 45. Notice the a value is not 1, so you'll have to be a little crafty on this. Same thing though for bonus points. I want the vertex. I want the zeros of the function. And I also want you to list the transformations from the parent function. So the transformations in order. Alright, so we'll go 5 minutes on this. Alright, here we go guys. Recording when this is, when the a value is not 1. Okay? And you may have to refer to these videos. I noticed some of you, when we're doing our notes, we're just writing on our desks. That's fine. I'm that same type of person. But make sure you take pictures of what you're doing so that you have something to refer to when we go back and you need to ask questions. So here we go. 3x squared plus 18x. They already are on their own side. The change is I need to change 3. I need to factor 3 out from what I have just on the left side, so my scraps are x squared plus 6x. This is the b. This is that b, that new b that I'm going to do b over 2 squared. Completing the square. So 6 divided by 2 is 3. Squared is 9. So how much am I going to add to the other side? 27 is what I'm going to add to the other side. So I'll get 12, 72. This becomes x. This becomes 3. Because you're square rooting them. And borrow that sign. Don't forget about your a value. Okay? So subtracting, I'll get y is equal to 3x plus 3 squared minus 72. My transformations in order, BCAD, just like with absolute value, will be a horizontal shift 3 to the left, then a vertical stretch by 3. We're going to be doing transformations with other functions throughout the year. We're not going away from that. Vertical shift 72 down. The vertex is negative 3, negative 72. The zeros, when I divide by 3, that cancels to 1. Is going to be what? 24? Right? So now I'm going to square root both sides, which should give me a plus or minus 24. Real quick, 24 is what? 4 and 6. The 4 will come out as 2, because the square root of 4 is 2. So I have x plus 3 is equal to plus or minus 2 root 6. So when I subtract 3, my first answer is a negative 3 plus 2 root 6. Well, my other one is a negative 3 minus 2 root 6. Yes, you could have put that as just one equation with the plus and minus, which accounts for both. Here we go. Ready? Here we go. Each circle is an answer. And instead of just 10 points, I want 20 points for each circle. 20 points for each circle. I will double your score if you got everything perfect. 1, 2, 3, 4, 5, 6. So it'd be 240 if you were perfect.